Hi everyone, I'm Haifeng from Tulane University. It's my pleasure to talk about our recent work on few-shot video classification. But before I introduce the specific works, we have to get familiar with this task. As we all know, for now, we can easily get abundant video materials from internet. Given them, we can train a deep neural network to understand the content of the videos. However, the training of a model requires abundant, well-labeled samples for model learning, which is time-consuming and expensive. So we try to explore the few-shot video action recognition. Few-shot classification means that we are given a few well-labeled samples and use them to learn a classification model. Alternatively, we can formulate a few-shot setting as one task. Concretely, each task includes one support set and the other query set. There are 6 categories in support set, and each class has key well-labeled samples. We expect to utilize the support samples as a reference to identify the unlabeled query samples. In addition, to train a model that can generate 2 new tasks with new class, we create multiple tasks as the training set to learn the generalization ability, and the training and the test set has no class overlap. For this task, recent few-shot video classification works achieve promising performance by capturing similarity across some support and query samples with the different temporal alignment strategy or learning discriminative features with a transformer. However, they ignore 2 important issues. First, it's difficult to capture rich intrinsic action semantic from a limited number of support samples with each task. Second, redundant and irrelevant frames in videos easily weaken the positive influence of discriminative frames. To address these 2 issues, this work proposes a new method with 2 sub-modules: meta-action learning and reinforced image representation. This is the overview of our proposed method framework. To overcome the first challenge, we propose the meta-action learning module, which introduces external knowledge learned globally to enrich video representation learned locally with each individual task. Specifically, this module maintains a global meta-action bank storing representation of automatic action snippets that can be used to form different action category or of high complexity. The global meta action bank is shared by all action types and all individual tasks. We explore it to enrich the video feature representation learned locally in each individual task with a new SVD technique. For the second issue, we propose the reinforced image representation module, which explores reinforcement learning to discover the importance of each frame to the few-shot video classification task. We train the reinforcement learning agent by exploring the relationship between support and query video pairs, aiming to emphasize the influence of discriminative frames to help the model accurately capture sample-wise similarity. These 2 modules can be easily plugged into the existing method to promote their performance. For the experiment, we evaluate our method on 3 popular few-shot benchmarking, include UCF, kinetics, and something to something. Moreover, we mainly plugged our method into 3 existing methods such as OTM, TRX, and STRM. From this result, we can know our method can effectively improve the performance of this method. In addition, we also compare the temporal alignment paths produced by the original OTM and our method. From this figure, it's simple to find that plugging our proposed module can enhance the relationship of similar frames and achieve better temporal alignment. Thanks very much for your listening.